If you get the low NO2 pressure reading, this might mean that the cylinder pressure gauge reads less than 14 bar, so it's in the red. Look at the display. The cylinder icons on the left hand side will be green on the cylinder that's switched on. Follow the grey delivery lead back to this cylinder. This is the cylinder you don't want to disconnect. Look on the cylinder head of the other cylinder. It should be in the red, so it's not switched on. This is the one you want to disconnect. Disconnect like a blood pressure pushing towards the machine. You now need to turn the cylinder valve anti-clockwise and then clockwise quickly to turn it on and off. You now need to purge this gas. So depress it in here to purge. This lead now can be replaced. You now need to turn one cylinder off and turn the other one on. So you're going to switch the valve on the one that's on clockwise so it's off, and quickly turn the new cylinder anti-clockwise all the way so it's open. You can check on the front display to make sure that the lit icon is on the other side. The Ino blender is a completely separate device that can be used independently of the main unit. It is pneumatically driven, so it doesn't use an electricity supply, and as such can be used in an electrical failure. The only lead that is connected to the main unit is a lead that provides nitric from the main cylinder supply. The intended use for the Ino blender is as a backup to a primary Inomax delivery system. If this system fails, it is intended to be used until a working primary system is found. Your water circuit or Mapleson C circuit should be connected to the Ino blender. In this way, if the patient needs to be manually ventilated, the Ino blender can be turned on and the nitric can be switched from the main unit to the O2 flow meter driven unit. It's really important though that the oxygen hose is connected, as otherwise you won't have an O2 flow. If the patient needs to be manually ventilated in an emergency situation, the Ino blender should be switched on to whatever nitric parts per million the patient is on, and the flow meter turned to 14 litres. One consideration though is that the nitric flow has now deviated from the main unit to the Ino blender, and if the sample line adapter is not connected in line with the water circuit, the dose that you're delivering won't come up on the screen. It's also important after you've finished bagging to switch the Ino blender back to 0 so the flow is deviated back to the main unit. Another option is the backup delivery system. Here we can see the injector module has failed. It's electrically driven. So when this fails, the NO will start to drop. The backup delivery system is pneumatic. When it is switched on, the backup delivery provides a fixed flow of 250 ml a minute of Inomax directly into the ventilator circuit through the injector module tubing. Here we can see the machine is alarming as the set NO and backup are on at the same time, so you'll need to turn this off. Now we can see just the backup delivery system is on and the nitric has gone back up. This method may be preferable in patients with high PEEP and O2 levels, as it means the patient does not need to be immediately disconnected from the circuit. During this time, the bedside nurse can gather the relevant staff to help the changeover to a working system. When this system is used, care should be taken to monitor the nitric oxide that's being delivered to the patient. This is because the NO dose delivered is completely dependent on the gas flow through the ventilator. As we can see here, a ventilated gas flow of 5 litres a minute will provide NO concentrations of 40. Ventilated gas flow of 10 litres per minute, NO concentrations of 20. And ventilator gas flow of 20 would provide NO concentrations of 10. As we have autoflow turned on all our ventilators, this regulates inspiratory flow and inspiratory pressure, delivering the set tidal volume at the lowest possible inspiratory pressure. This means it's very difficult to measure the flow going through the ventilator as it's constantly fluctuating. This mode is not intended though for extended use. It should only be used until a working machine is tested and the system is exchanged. One way of increasing and decreasing the nitric oxide being delivered during this mode would be to change the respiratory rate, reducing to increase the nitric dose and increasing to reduce, although this should only be done with consultant approval. If both nitric machines are being used and it's an injector module failure, not a delivery failure, it might be deemed safer to change the injector module for a spare one rather than waiting until another machine can be borrowed from another unit. Again, the options here are either manually ventilating the patient using the Ina blender or switching to the backup delivery system. There is a spare injector module with the nitric consumables in B3 North's vent room. The middle corrugated part of the end of the cable needs to be pulled back towards you so the lead can be removed. You now need to line up the red dots and put the new cable on. This is where you might need to assess if the tube needs to be clamped and get the relevant assistance, as you now need to replace the injector module on the inspiratory outlet. When this is done, you can now turn the dose back to what it was and switch back over to normal therapy.